When you look up at the night sky, space seems very far away. You see stars, planets, perhaps the moon. It feels like a distant realm, separate from our daily world. But this is not entirely true. Space technology is much closer than you think. It is already woven into the fabric of our lives. It touches us in countless ways every single day. We often use it without even realizing its cosmic origins. It silently, powerfully shapes our modern existence. Think about your average day. Perhaps you checked the weather forecast this morning. That information likely came from satellites orbiting Earth. Maybe you used a map on your smartphone to navigate. That too relied on signals from space. These are just a few examples. Satellites are unsung heroes. They are our tireless assistants in orbit. They work constantly providing data and services. These services make our lives easier, safer, and more connected. It is a profound link. Many people associate space technology with grand missions, astronauts walking on the moon, or rovers exploring Mars. These are indeed incredible achievements of human ingenuity. However, the everyday impact of space tech is often less dramatic. It is quieter, more subtle, but incredibly powerful. It resides in the constant stream of data transmitted by hundreds, even thousands of machines. These machines are satellites circling our planet. They form an invisible yet vital infrastructure. This essay will journey through these connections. We will explore how satellites power our daily routines. We will see their role in guiding our travels. We'll learn how they help us grow food more effectively. We will understand how they connect us to the internet, and how they warn us of dangerous weather. Space, you see, is not just for astronomers or astronauts. It is an integral part of your life right now. Let us embark on this exploration of our cosmic helpers. Can you recall the last time you were truly, hopelessly lost? For many people, it has been a long time. The reason for this is a remarkable technology. It is called GPS. GPS stands for Global Positioning System. This system can tell you your precise location. It works almost anywhere on Earth, on land, on sea, or even in the air. It is like having a magical map. A map that always knows where you are. This magic is made real by science and satellites. So how does this extraordinary system operate? It relies on a constellation of satellites. There are at least 24 operational GPS satellites. They orbit the Earth at an altitude of about 20,000 kilometers. Each of these satellites continuously transmits signals. These signals contain information about the satellite's position and the exact time the signal was sent. These signals travel towards Earth at the speed of light. Your smartphone or dedicated GPS device listens for these faint whispers. To determine your location, your GPS device needs to receive signals. It needs to hear from at least 4 different satellites. Each signal helps the device calculate its distance from that specific satellite. It does this by measuring the time it took for the signal to arrive. Imagine drawing spheres around each of those 4 satellites. The radius of each sphere is the calculated distance. The point where all 4 spheres intersect is your location. Latitude, longitude, and even altitude are revealed. Therefore, the next time you glance at a map on your phone, or when your car's navigation system confidently guides you, take a moment to appreciate the unseen ballet above. Dozens of sophisticated machines are orbiting our planet. They are constantly communicating and coordinating. All of this intricate technology works together, just to ensure you can find your way. It is a silent, daily miracle of engineering, powered by the cosmos. The Global Positioning System is renowned for its navigational prowess, but its capabilities extend far beyond simply telling you where you are. GPS is also a source of extraordinarily accurate time. Each satellite in the GPS constellation carries multiple atomic clocks. These are not your everyday wristwatches. Atomic clocks are paragons of precision. They measure time with an accuracy of a few nanoseconds. That is a few billionths of a second. This incredible timing is crucial for many modern systems. These precise timing signals broadcast by GPS satellites are fundamental. They serve to synchronize a vast array of critical infrastructures globally. Consider the world of finance. When you use an ATM to withdraw cash, or when you make a purchase online with a credit card. These financial transactions require exact timestamps for verification and security. GPS provides this universal time reference. It ensures that financial networks operate smoothly and reliably, keeping global commerce in sync. Power grids, which supply electricity to our homes and businesses, also depend on this timing. Different sections of a large electrical grid must operate in perfect harmony, precise synchronization prevents overloads and devastating blackouts. Mobile phone networks are another example. They need accurate timing to manage calls effectively, and to ensure seamless data transfer between cell towers and your device. GPS underpins this complex coordination. It is a hidden layer maintaining order. So GPS is far more than just a digital map. It functions as a global utility of immense importance. It provides a universal, highly accurate clock. This cosmic clock helps to regulate and run our complex, interconnected world. From financial systems to telecommunications, from scientific research to emergency services, the steady, rhythmic pulse from orbit, it ensures the intricate machinery of our modern society continues to function effectively. We often take the internet for granted. It feels like a utility that is simply always there, like water or electricity. However, this is not the case for everyone. Vast regions of the world still lack reliable internet access. This is particularly true in remote, rural areas, and in many developing nations. Laying physical fiber optic cables across difficult terrain or oceans is challenging. It is also incredibly expensive. Satellites offer a powerful alternative, a way to beam connectivity down from the sky. Traditionally, internet-providing satellites have been positioned very high above Earth. They reside in geostationary orbit, approximately 36,000 kilometers up. At this altitude, a satellite appears to stay fixed over one spot on Earth. This is useful for continuous coverage. However, this great distance poses a challenge for internet signals. The signals have a long way to travel. This results in a noticeable delay known as latency. High latency can make activities like online gaming or real-time video calls frustrating. But new technological advancements are rapidly changing the satellite internet landscape. Innovative companies are now deploying large numbers of satellites. These are placed in much lower orbits. This is known as low Earth orbit, or LEO. LEO satellites orbit at altitudes ranging from a few hundred to a couple of thousand kilometers. Because they are closer to Earth, the signals travel a much shorter distance. This significantly reduces latency. The internet experience becomes much faster, more responsive. This development unlocks tremendous potential for global connectivity. Imagine students in a remote mountain village accessing online educational resources, or doctors in isolated communities conducting telehealth consultations, or researchers on a ship in the vast Pacific Ocean streaming data. Satellite internet is evolving into a viable, high-performance option. It holds the promise of bridging the digital divide. It can connect the remaining unconnected corners of our planet, bringing information and opportunity to all. Section 5. A sky full of data. Starlink and the new internet race. One of the most prominent names in the new satellite internet era is Starlink. This ambitious project is operated by SpaceX, the aerospace company founded by Elon Musk. Starlink's goal is to deploy a massive constellation of small satellites, potentially tens of thousands of them. These satellites will interlink to form a vast network in low Earth orbit. This network is designed to provide high-speed, low-latency internet access to virtually any location on the globe. Many users are already experiencing its benefits. Starlink satellites are relatively compact and are mass-produced. They are typically launched in large batches, with dozens lofted into orbit on a single rocket. This strategy allows for the rapid build-out and expansion of the constellation. However, Starlink is not alone in this endeavor. Other major players are also entering this new internet race. Amazon, with its Project Kuiper, has similar ambitions. OneWeb is another significant company deploying its own LEO satellite network. The competition is fierce. This intense competition among satellite internet providers is generally beneficial for consumers. It can lead to more choices, potentially lower prices, and improved service quality. But the proliferation of thousands of new satellites also raises important concerns. The skies are becoming increasingly crowded. This elevates the risk of space debris and in-orbit collisions. Astronomers also worry about the impact of these bright satellite trails on ground-based observations. We must develop clear regulations for this new space age. These burgeoning LEO satellite networks represent incredible achievements in engineering and logistics. They promise to revolutionize how humanity accesses information and communicates. The long-held dream of a truly globally connected world seems more attainable than ever. It is being brought closer to reality by these intricate constellations, these swarms of small, powerful machines, all orbiting silently, diligently high above our heads. We are witnessing a transformation. Section 6. Eyes in the Sky Weather Forecasting from Orbit. How do you decide whether to carry an umbrella or wear sunscreen today? Chances are you consulted a weather forecast. A significant portion of the data that informs these forecasts comes from space. Weather satellites are humanity's vigilant eyes in the sky. They continuously monitor Earth's atmosphere and weather systems. They operate tirelessly day and night in sunshine and storm, providing a global perspective that is impossible to achieve from the ground alone. They are essential tools. These sophisticated satellites are equipped with a variety of advanced instruments. They carry specialized cameras that can see clouds in visible and infrared light. They have sensors that measure temperatures at different altitudes in the atmosphere. They can track wind speeds and directions over vast oceans. They can detect moisture content, ice cover, and even volcanic ash plumes. This comprehensive data stream allows meteorologists to see the bigger picture, to understand how weather patterns are developing and moving. Consider the critical role satellites play in tracking dangerous weather phenomena, such as hurricanes, typhoons, or severe thunderstorms. Satellites can often detect these storms in their earliest stages of formation, long before they pose a threat to land. They meticulously track the storm's path, intensity, and size. This information is absolutely vital for weather forecasters. It enables them to issue timely warnings to communities in the storm's path, allowing people to prepare or evacuate, ultimately saving lives. Beyond daily weather forecasting, satellites also contribute immensely to our understanding of long-term climate change. They provide continuous, global measurements of key climate indicators. These include sea surface temperatures, sea level rise, and the extent of polar ice caps. They monitor greenhouse gas concentrations in the atmosphere. This invaluable data record, often spanning decades, is crucial for climate scientists. It helps them build accurate climate models and to predict future environmental changes. Section 7. Farming from space. The satellite revolution in agriculture. Farming is an ancient practice, deeply rooted in the land, yet it is currently undergoing a high-tech transformation, thanks in large part to space technology. Satellites are becoming indispensable tools for modern farmers. They are helping to grow more food, more sustainably, and more efficiently than ever before. This evolving field is known as precision agriculture. It is like equipping farmers with a sophisticated, data-driven toolkit. A toolkit powered by observations from orbit, helping to feed a growing world. Satellites orbiting Earth can capture highly detailed images of agricultural fields. These images, taken across different wavelengths of light, reveal a wealth of information. They can indicate the health and vigor of crops. They can pinpoint specific areas within a field that are stressed, perhaps due to a lack of water, insufficient nutrients, or an infestation of pests or disease. Farmers can access this information through specialized software, often on a tablet or smartphone. It's a diagnostic tool for their land. GPS technology, which we discussed earlier for navigation, also plays a crucial role in precision farming. Modern tractors and other farm machinery can be equipped with GPS receivers. These allow for highly accurate guidance across the fields. Farmers can use GPS-guided equipment for precise planting of seeds, for the targeted application of fertilizers and pesticides, and for optimized harvesting. This reduces overlap and waste of resources like fuel, seeds, and chemicals. It saves farmers money. This integration of space technology into agriculture leads to significant benefits. It can help increase crop yields substantially. It makes farming practices more environmentally friendly by minimizing chemical runoff. As the global population continues to expand, the demand for food will only grow. Satellites are a vital component in meeting this challenge. They empower farmers to make better-informed decisions, to work smarter, leveraging data from hundreds of miles above, to cultivate the future. Section 8. The new space rush. Companies vying for orbital dominance. We are currently witnessing a new and dynamic era of space exploration and utilization. It is often described as a new space race. However, unlike the Cold War space race between nations, today's competition involves a vibrant mix of players. Established aerospace giants, innovative private companies, ambitious startups, and even universities. They all recognize the immense economic and strategic opportunities that lie in Earth orbit and beyond. Billions of dollars are being invested. It's a fervent rush. A key driver of this new space age is the dramatic reduction in launch costs. Companies like SpaceX, with its reusable Falcon rockets, and Blue Origin and smaller launch providers like Rocket Lab, They are revolutionizing access to space. Reusable rocket technology means it is no longer as prohibitively expensive to send payloads into orbit. Cheaper and more frequent launches are unlocking a wave of new possibilities, enabling more satellites to be deployed for diverse applications. Many new space-based businesses are emerging. The rise of small satellites, particularly CubeSats, is another significant factor in this boom. CubeSats are miniaturized satellites, often no larger than a loaf of bread or a shoebox. They are significantly cheaper to design, build, and launch compared to traditional, larger satellites. This has democratized access to space. Universities can now afford to conduct their own space-based research. Small companies can test new technologies or offer niche services from orbit. Innovation is flourishing. This rapid expansion of activity in Earth orbit is incredibly exciting. It is fostering innovation at an unprecedented pace. However, it also presents new and complex challenges. The sheer number of satellites is increasing concerns about space traffic management. The risk of collisions between active satellites or with space debris is growing. International cooperation and robust regulatory frameworks are urgently needed to ensure that space remains a safe, sustainable, and accessible domain for all, for current and future generations. Section 9. Tomorrow's orbit, the future of satellite technology. Satellites have already profoundly reshaped our world in countless ways, from communication to navigation, from weather forecasting to resource management, but their journey of innovation is far from complete. The future of satellite technology promises to be even more transformative. We can anticipate a host of new capabilities and applications, many of which will further enhance our daily lives, often in ways we might not yet fully comprehend. The sky is truly not the limit. Imagine the role of advanced satellite systems in disaster response and humanitarian aid. Following a major earthquake, a devastating tsunami, or widespread flooding, satellites could provide immediate high-resolution imagery of the affected areas. They could establish emergency communication networks when ground infrastructure is damaged. This would enable rescuers to locate survivors more quickly, and allow aid organizations to deliver assistance more effectively, saving more lives more efficiently, a powerful prospect for humanity. Satellites will also play an increasingly critical role in monitoring the health of our planet. They could track deforestation and illegal mining activities in real time. They could help locate new sources of fresh water in arid regions, or monitor air and water pollution with unprecedented accuracy and scope. This continuous stream of environmental data will be invaluable. It will empower us to manage Earth's precious resources more wisely, guiding us towards a more sustainable and resilient future, protecting our home. And what of more ambitious ventures such as widespread space tourism, in-orbit manufacturing, or even resource extraction from asteroids? These concepts, once the domain of science fiction, are steadily moving closer to reality. As the underlying technologies mature and costs decrease, satellites will form the essential backbone for these future endeavors, providing communication, navigation, and observation capabilities. Our intricate dance with space technology will only deepen, powering ever more aspects of our world.